Do you guys know that we have mites that settle on our eyelids, just like all over our body? And if you don't clean your eyelids properly, they start to leave their deposits along your eyelashes.
I think I'm on the wrong podcast here. Let me check.
Nope, this is it.
Yeah, what the heck?
Podcast. And welcome everybody to it. My name is Matt Kimball. I'm joined by the beanie-wearing Will Townsend and the vest-wearing Paul Smith-Goodson, both stereotypes of the tech culture. And we are here to talk all things data center and iMites. Before we get into our fun discussion, I just want to tell you that if you take a single word of what we say as serious investment advice, you deserve all the bad luck that comes to you. So please don't do it. Before we start, please like and subscribe, because I have a feeling that by the end of this podcast, you will not like nor want to subscribe. So please do that ASAP. And let me just finish on my thought, guys. So dust mites, if you don't clean your eyelids properly, they eventually leave their deposits and you start getting like a red rim around your eyes that you have to use a cloth to wipe out. And if that doesn't work, you need drops. I won't tell you how I know this. I will just tell you I know. And if my eyes look a little redder today, I'm going to leave it at that. Okay?
Okay. All right.
Any questions for the teacher?
You know, when you get to quantum iMites, let me know.
I have quantum resistant iMites. All right, here we go. We are here to talk AMD, Microsoft, quantum physics, Cisco, NVIDIA. Wow, NVIDIA, IBM, we're hitting them all, and iMites.
Yeah.
Let's jump right in. I think Mr. Townsend is going to lead us off with some discussion around AMD's keys to the kingdom. What a way to start a Thanksgiving week. What do you got, Will?
How about that headline for creativity, right?
It's okay. It's not Paul Smith-Goodson level, but it's good.
It's adequate, right? So, well, hey, this is related to a recent announcement by AMD, Cisco, and Humane. They're forming a joint venture to deliver world-leading AI infrastructure for the Middle East, Saudi Arabia, the UAE, that whole area of the world. And this builds upon a very, very strong partnership between Cisco and AMD with smart switching and scale up and scale out networking and that sort of thing. Basically, the joint venture is to deliver up to 1 gigawatts of AI infrastructure by 2030, starting with a 100, megawatt deployment in the Kingdom of Saudi Arabia. And I like this. Matt, you and I have been talking about NVIDIA versus AMD, and AMD is very, very quickly, positioning themselves as, a very strong number two, not to quote Austin Powers, but I think there's a lot of goodness with this, and it just continues to solidify that strong second position to NVIDIA. I like this. Cisco is innovating like nobody's business these days. They're, and I'm going to talk about this a little bit, more and with my second topic. But they're beginning to morph from just sort of a network only solution provider to an AI infrastructure provider. And I like this, and I like the opportunity for AMD. I like the opportunity for Cisco, and Humane stands to benefit. That part of the world wants to lead with respect to AI data center deployment. And I think this is a strong, indication that they can get there. So what do you think, Matt? I know you've got some thoughts on this subject.
Me? I never have thoughts. I'm just a good-looking guy. I'm just a good-looking talking head, like a newscaster.
There you go.
So here's what I think, and I'll be quick, and I know Paul has thoughts as well. I think the AI game is wide open. And I think AMD trying to attack NVIDIA on a kind of frontal assault kind of model where, you're going in and you're going into, the kind of the foundation models here in the States and trying to replace them is a waste of effort. I think going to where the greenfield opportunities are is really, really smart. And
Mhm.
I think these kinds of wins are going to all collect over time and give AMD a strong gravitational force in the AI space as it relates to training. I think inference is wide open. And I don't think that's
Yeah.
anybody's game. I don't think it's NVIDIA's game. I don't think it's AMD's game. I think it's both of theirs and then a whole
It's
bunch more.
broad.
Yeah.
Yeah, it's super broad, right? Yeah.
Yeah. But I think on this training side, I think I like what AMD is doing. And you see what's going on with Cisco and Humane. You see that Oracle's deploying, OCI is deploying a bunch of AMD. You see Azure is going to stand up more AMD. You see the agreement with OpenAI and kind of investment in building their ecosystem. And before you know it, you wake up one day and you think, CUDA, who cares? Because all of these parties working to optimize ROCm as a development platform for AI are going to build in the richness and the touch points with CUDA, so that that moat that has been built is going to be torn down completely. And that's where I think AMD has a competitive advantage, because their hardware is actually their chip is actually a better chip design than NVIDIA's right now. When you look spec for spec, when you look at HBM, when you look at core counts, it's actually I don't want to say better. It's a very, very strong part. And where AMD is killing them is on the software side. So I think this is a really good play for them. And Paul, I'll let you jump in. Sorry.
Yeah, I don't have a lot, but when you look at the partnership, I mean, it's a high stakes competition. I mean, AMD's in a really competitive market, with NVIDIA. And you got to make sure that it's 450s. I think 450s are not only competitive in performance, but that it can keep up with the manufacturing and allocate hundreds of thousands of these chips for this joint venture, and then take care of the rest of the hyperscalers that need them. So.
Yeah. Yeah, that's a good point on the manufacturing front. And it's going to be interesting to see how this plays out, not just on. So you're jumping ahead a couple of years on the 450, but the 400, the 450, and the advanced manufacturing node that they're going to be moving to, and whether that's, not to go off on a tangent, but whether that's an exclusively TSMC play, or if Intel, strangely enough,
Get some.
Yeah, because that is,
We lost him. Can you hear me?
We lost you, Matt.
Yeah.
Yeah, we lost Matt.
Those eyelid mites got to him.
Well, hopefully he'll come back here.
Yeah.
Because he's our showrunner.
Yeah. I think he's tricking us. He's just being really still.
And I think I just lost you guys. How do you like them apples?
Oh my goodness.
The joy of going. Where did you guys?
What happened?
I'll tell you what happened was I had my VPN on, and I love ExpressVPN. Shout out to ExpressVPN, but this happens on occasion where it just seems to lose its way, and before you know it, I've got spinning wheels. Where did you guys lose me? Did you lose me at hello?
Yeah.
Pretty much.
Yeah. Difference between 400.
We might want to wrap this one up.
Yeah. All right. Sorry about that.
450.
Just saying, keep an eye on Intel from an advanced manufacturing perspective. I think there's a lot of opportunity there.
Yeah.
Holy heck.
For
All
sure.
right. That's live, guys. That is live. All right. Let's move on. I guess it's my turn now. Let's move on to this fun discussion around holy hell, let me get arranged here. Around Microsoft and their announcements at Ignite last week. I know. Now I'm all thrown off my game. Paul, it's your fault. So Microsoft held their Ignite event last week, and as part of that, they made a bunch of announcements around Foundry, which is their AI play, MCP, kind of agentic goodness. But they also announced, and that took, I think, center stage for folks, but they also announced the launch of the Cobalt 200. Really, really interesting play here. So for folks that don't know, Cobalt is Microsoft's ARM-based CPU. It plays into their Azure data center, and like Graviton from AWS or Axion from Google or Ampere at Oracle, it is the ARM-based platform. Oracle 100, or I'll go quickly, Cobalt 100 came out. Really interesting play for kind of internal workloads and some lightweight workloads. It was kind of a pipe cleaner. Let's prove this thing works before we get serious about supporting it. And lo and behold, at Ignite, Microsoft showed that they were serious about it and launched the Cobalt 200. 192 cores, bunch of memory, latest specs on everything. I think it's on TSMC's 2-nanometer process. I could be wrong. But it's just a richness of features that is supporting scale up, scale out workloads. And it's Microsoft's kind of play in the, hey, Graviton's great, but so are we as it applies to or pertains to ARM. Here's why I think it's really interesting. AWS has done a great job of seeding the market with ARM and Graviton. And some would say, I think there are actually some predictions out there or forecasts out there that say Graviton is now 50% or greater than 50% of all of the new AWS deployments that are going on in their data centers, which is crazy and a significant hit to AMD and Intel. Microsoft is, as everybody knows, is the traditional enterprise play. You're a traditional enterprise IT organization. You're deploying a bunch of stuff up into Azure. By Microsoft saying, hey, this Cobalt 200, this ARM-based instance is as good, if not better, than its x86 peers in terms of price performance, is a huge, huge endorsement of ARM. And it really kind of normalizes ARM in the enterprise virtual data center, meaning, wherever I run my workloads, right? It gives enterprise IT permission to start viewing ARM as a legitimate source or destination for those workloads. This to me means a few years from now, as we start seeing refresh cycles and we start seeing kind of this stronger march toward ARM, you're going to start to see ARM come on-prem, which is going to be a really big tipping point for our folks and our friends sitting in Hillsboro, Oregon, and sitting in Austin, Texas, because they're going to have to respond in ways they haven't yet. So really great play. I love what Microsoft is doing with Cobalt 200. More importantly, I think this is a really strong signal for ARM in the enterprise, and I'll stop at that.
Good stuff. Nothing to comment on there, Matt.
You guys are boring. No feedback. What are you already thinking about turkey?
It's Monday, and I'm already thinking about turkey. So.
Paul's looking at me suspiciously. So this is not a good start.
It involves transitioning a big chunk of a multi-billion-dollar global data center to a custom design processor. It's got to be kind of a nail biter, I would think,
Well, here's what's so interesting about what they've done, and I'll go quickly so we can transition and we don't have any more pauses and breakups. Here's what's really interesting about that, Paul. The way that AWS handled Graviton, the way Oracle's handled Axion, and the way Microsoft has handled Azure is deploying is easy. It's just a standard server rack. Well, that's not the case with AWS because they do things differently. But it's just a standard server with standard tooling. And they've built enough abstraction that porting workloads and moving workloads is simple as point and click. You don't have to go down to binaries. You don't have to recompile. You don't have to do any of that weird low-level stuff, because everything sits on top of an abstraction layer. And so it makes it far more easily. Oh, and by the way, for where you are running things raw, databases and things of that nature, every major software vendor has built in the hooks for ARM so that it is as supported as its x86 brethren. So that nail-biting functionality that existed a few years ago, it's largely going away. And it's going to go away more and more as we get closer and closer to this kind of end state of just autonomous data centers. So super fun stuff.
Yeah.
Anyway, shut up. And we're going to jump on to QEC versus QED. Will, you are so impatient. I can't stand you today. Oh my gosh. Somebody cut his camera. All right. QEC is QED. This is a boring headline, Paul. Not like you. Jump in.
It's exciting stuff behind it.
Let's go.
You guys know what QEC is, quantum error correction. And I know you know what QED is. So I think IBM and 3 will solve the quantum error correction problem, or made a big contribution to it. I mean, error correction has been a problem for years with quantum, you guys know. And IBM's come along with a really nifty solution. I mean, we've been working on it since 1995 when Peter Shore came up with his idea, and it's evolved into a whole different number of different solutions. And IBM has got one that they're using an FPGA for a decoder, and it has really ultra low latency, and it really kind of validates the path to get to fault tolerant computing. I mean, I was really surprised for it. They just put the paper out, I think it was this month, about it. The project was, if you look at the IBM roadmap, they completed a year ahead of time, and I think the FPGA solution contributes to that. So it has to be fast. IBM, is superconducting, and a quantum computer operates. IBM quantum computer on superconducting operates on microsecond time scale, so everything's got to be really fast. The superconducting qubits have got a short coherence time, a couple hundred microseconds. So that tells you there's a lot has to be done in that time. And a quantum state, you'd like to have the quantum state hold up as long as possible, but it degrades really fast, and you can't just simply fix an error. You've got to find it, and then you've got to correct it faster than new errors come in on top of it, because that'll cause the system to go upside down. So it fundamentally requires full-time decoding, and you can't let a quantum circuit run more than 1 or 2 operations, or if you get behind it, then that's what happens. What IBM has done is implemented a special algorithm, and they've done it on an off-the-shelf AMD FPGA. It's not anything sophisticated. I mean, it's literally off the shelf. And then they implement this algorithm on it, and that translates syndrome data from a circuit into error correction information for codes that sit inside the processor. Syndromes are, I don't know how to explain it. Syndromes are kind of like diagnostic patterns, or they're like error signatures or something that indicate something's gone wrong with a qubit. And it does that without, it doesn't destroy the qubit or the quantum information, which is important. Syndrome is kind of like a lights on a car dashboard. I mean, tell you there's a problem. Maybe the generator's gone out or something, but you don't have to take the whole engine apart to find out. So that's why this is kind of important. I mean, they can find out where the problem is and what the problem is in a circuit. There's a long process that goes through. Basically, checks for relationships between not only one qubit but multiple qubits, and then the measurements are the ones that are produced. They produce the syndrome data, and out of that syndrome data, then a pattern of different measurements come out of that. So they know where the error is, where qubit it's on, how to correct it, and that type of thing. So anyway, it's really neat. The FPGA can finish a decoding task in under 500 nanoseconds.
Oh wow!
Like I said, it's just standard off-the-shelf FPGA. Nothing custom about it. And because of the cycle times are so fast, this FPGA corrects the problem 20 times faster than it really has to. So there's a lot of room, a lot of overhead for it. So I'm looking forward to more on it, and I think it does in fact outperform GPU-based solutions by about an order of magnitude. So.
Hey, Paul, quick question for you before we go on to Will. So you mentioned, they're using an off-the-shelf, I'm guessing Xilinx, AMD FPGA to kind of drive this. Is that something that eventually becomes an ASIC?
Yeah, I would think so. Yeah.
Yeah. Okay. Yeah. Okay.
Gotta have the timing though. That's the problem.
Yeah.
If you look at the GPU, the time it takes a GPU to initialize exceeds the entire decoding time of the FPGA. So
that's incredible. That is incredible. Wow.
Yeah.
Quantum is real, baby.
Yeah.
We've messed around with error correction for so long. I mean, this kind of proves that error correction can be done, with something existing and it's affordable. You don't have to have any unique or wild configurations to do it. So.
Paul, I've been messing around with error correction my whole life.
I know.
Type of error correction.
How long have you been married?
This predates marriage. All right, here we go. All right, let's, because that's my therapy session, which follows this. Hey, Will, so Cisco's AI ambitions. Cisco has AI ambitions. What? What's this? What is this?
I think they do. Yeah, you and I have been to a couple live events. So yeah, so I wanted to start broadly and then talk about a specific recent acquisition that Cisco has made. But if you look at the last 18 months, I mean, Cisco has been sort of on an innovation tear, and it's not just been focused on its traditional networking infrastructure, right? So it is a wholesale sort of reimagination of the portfolio. They are simplifying the portfolio, moving away from Meraki and Catalyst because that was something that needed to be done for quite some time. They are tripling down on security with G2 Patel. Now, we've mentioned how G2 is the president and chief product officer managing both the networking and security portfolios. And Cisco's strategy is to embed, integrate security into the networking layer. Very different than, say, Arista's strategy, where they're going to focus on networking, what they do well, and they're going to partner with best of breed from a security standpoint. But it's just been a lot of innovation. Hypershield, Agentic Ops most recently, and AI Canvas. And AI Canvas is something that I wrote about in a Forbes article this year. And so sort of to continue that innovation momentum, Cisco announced its intention to acquire a startup and closed it very quickly within a matter of a couple of days. The company is Neural Fabric. And they weren't on my radar screen, but apparently they have some fairly deep capabilities from an IP perspective that Cisco believes is going to help them develop and strengthen that AI Canvas piece of their portfolio, which I refer to as the tip of the spear for a lot of what they're doing. If you're not familiar with AI Canvas, it's a customized, highly generative dashboard that they are basically deploying across the entire portfolio as sort of a single pane of glass. Apparently, what Neural Fabric brings is some strength with helping to develop smaller language models, streamlining training, and providing flexible deployment options. What I find interesting about this acquisition is
What's the name of the company again?
What's that?
What's the name of the acquisition again?
Neural Fabric. Neural Fabric. And what I find interesting about the timing on this particular acquisition is that it fast follows a recent product announcement around Cisco's Unified Edge, which I believe we've spoken about on a prior podcast, which is bringing basically portability to the edge of a network to run some of these AI workloads that are going to be run on smaller language models, versus larger language models that are typically, always cloud hosted. So I like it. I don't know a lot about the company, but it's certainly what Cisco believes it's going to do. It's going to help refine what it's doing with AI Canvas, number one. And number two, I think, it's too early to tell, but I really like that unified, edge announcement that the company also recently made. I do believe that it's going to provide some value there just because it's very focused on these smaller language models. So thoughts? Matt, what are your initial thoughts?
The reason I asked you, go ahead.
You go, Paul.
Okay. The reason I asked you, I had read something about Neural Fabric a while back. Anyway, it's a small company. And I think they got 9 people or 10 people, something like that.
Right. Yeah.
And they've got, but they're all veterans of Microsoft, I think.
Okay.
And the problem is that when you get a small company like that, I mean, I've been through it, is that, it's like a family. And when there's any problems, any friction or anything, and then the key people leave, then that really causes problems with the knowledge and the technology and that type of thing. So that's the only thing I've comment about. But I'm sure it's going to work out.
Yeah, no, hey, Cisco's got a big checkbook. I'm sure, they paid, adequately for it, and they probably have provisions in place to make sure that, there's the, transition of IP and intellectual knowledge. But yeah,
I think it's probably an acquisition that is as much focused on the people as it is the technology. Usually those
for sure
smaller acquisitions tend to be kind of, let's get this really great talent. And I could see where that friction was a consistent theme for Paul, because he's a rabble rouser. So I could see him being in companies that got acquired and him rebelling against the man, so to speak. But here, I will say this. I think the world, while we're living in a foundation model world today, and I've said this a million times, we're going to quickly evolve, which means maybe more than evolution, to a world of small language models that are running across an enterprise and having to work with one another to achieve this agentic, autonomous kind of model that everybody has visioned. So because of that, I think it's fantastic. By the way, I love what Cisco is doing. Their ambitions, I think, are recognized. What Danny McGinnis has done with that unified edge and kind of the computing portfolio in particular, or in general, is a really good story. I love the Canvas AI. And then I think even, I think I've heard them get dinged. And by the way, I've dinged them as well a few times on the whole notion of kind of the lack of storage component to their strategy. But I think they're taking a smartly pragmatic view of the world, in that enterprise organizations don't want to rip and replace a bunch of storage that they've invested in over the decades. They'd rather leverage it So working with partners to light that data up, and actually just met with Nick Sagnas, who's the product lead on the distributed data side, around how they're working with partners to take all this disparate data, all of this kind of, you call it dark data and locked data, and bring it into and feed those GPUs quickly. They're doing some really smart stuff in enabling that kind of feeding of those AMD or NVIDIA GPUs. So I love what they're doing. I think and they're well positioned, I think.
Yeah, and like to your point, Matt, it's the momentum is with modern AI, it's moving hybrid. So we'll still have those larger foundational models in the cloud, smaller language models on the edge. And and I think, Cisco doesn't need to go buy or acquire a storage solution, to your point. That there's value in working with, all of the, storage solution providers out there, right? Yeah. Because to your point, storage typically gets installed and it's around, for decades, right? Yeah. So I don't see any value in Cisco having to acquire a storage, solution to sort of complete their broader AI ambitions. And by the way, the stock has been on a tear as well. So Wall Street is also embracing what we're talking about today.
Yeah. So. Yeah. If you look, look, VAST is like the darling of storage and data management in the AI era, with good reason, because it's amazing technology. And Cisco has a very tight relationship with them. Pure has a very strong reputation and position in enterprise storage. And for those enterprises that are evolving to this AI model, and Cisco has a great relationship with them. NetApp, likewise, Cisco has a great relationship. So they're leveraging what is already sitting in your data center or what you're thinking about to enable. So I think they're good. And by the way, I disagree with you on one thing there. I don't think small language models are the exclusive domain of the edge. Small language models are going to sit in an HR department that has an HR specific model. They're going to sit in an ERP or a supply chain team that is using supply chain management. Yeah. They're going to across, and they're going to talk with one another. Sometimes they're going to talk to foundation models as well, and sometimes they're just going to run independently. But I think they're going to be everywhere, and that's where I think this is going to be a super interesting. I know you didn't. I was just trying to be controversial by saying I disagree with you.
No. It's a solid observation. I probably sort of, overgeneralize the whole, kind of where putting this infrastructure where, data is created. You're absolutely right. I mean, I talk to like lots of enterprises, and they do exactly what you just described with the HR examples. So thank you for
fight back. Controversy in this Discord is what drives viewers. You got to fight back. Right, Paul?
Right. Yeah, you got it.
Thank you. Lover, not a fighter.
That's art. There's an argument on both sides of that. All right, here we go. Let's go on to the next one. This is a good one. Struggling with AI chips. Here's a thought. That sounds like a Paul Smith. That sounds like a proper small Paul Smith Goodson headline. However, it's not. It's mine. It's how you rip off Paul. And I didn't use ChatGPT. So I kind of put this out there because I was interviewed, NVIDIA had their earnings announcement, I think it was last week. And in there, they talked about supply chain challenges heading into 2026 and beyond. And I got pinged by a couple of journalists on, hey, what does this mean, right? And it got me going down this kind of exercise of kind of thinking this through. And I just kind of want to talk it through a little bit. So supply chain issues around NVIDIA are real. Supply chain issues around AMD are going to be real. But here's what I think is going on in the market. I think we're looking at things a little bit too narrowly. And I think we need to kind of step back, especially as we get to enterprise AI. We need to step back and think about what we're talking about. When NVIDIA is going to have a supply chain issue in 2026, it's going to be around the GB300, the B300, or maybe the Vera Rubin or the Rubin series GPUs. That means there's a B200, available. That means there is an H200 GPU available. When AMD has supply chain limitations, it's going to be around the MI400, the 425, 450 heading into 2027. That means the 355 is available. That means the 300 is available. There is a lot of GPU compute out there, and I know a lot of it's being consumed already. But I think enterprise, talks to a larger issue. And it's something I run into when I talk to enterprise IT folks a lot. And that is, and hear me clearly on this, enterprise IT, you do not always need the latest and greatest technology from the likes of NVIDIA, from the likes of AMD, from the likes of Qualcomm, and from the likes of others to achieve your AI goals. You okay there, Paul? I think I
had to let my dog out. He was scratching my door.
I thought you were getting in a sword fight.
Yeah.
I was invading your office.
Boy,
Sorry.
what an episode we're having today.
You don't need the latest and greatest technologies. If you add an hour to your training time because you're running on the 355 instead of the 400, or even a couple of days to your training time because you're running on the H200 instead of the B300, you're going to be okay. Where it really matters is when you're inferencing. And inference is where the rubber hits the road. It's where AI is realized by your customers, by your partners, and by your employees. So think more holistically about how you're approaching your AI journey. And think about the investments you're making as an enterprise IT organization. Do I want to pay top dollar and get on a waiting list that is going to be dominated by the largest of cloud providers and then the neo clouds, or you can get supply? Or do you look at maybe kind of refocusing kind of how you're approaching this and think about the GPUs you're going to be deploying around your enterprise? I'm not saying don't buy NVIDIA. It's a great company, great chips, great people. I'm not saying don't buy AMD. Same story. I'm saying think about what your needs are and think about what parts are best fit into your performance per dollar and performance per watt, but really performance per dollar kind of metric that you've established as your go, no-go kind of touch or benchmark. That's what I would be doing, and I'd stop worrying about Vera Rubin versus the MI455. If you're in enterprise IT, those are probably not the right fit for you anyway. End of rant. You guys go ahead and tell me why I'm wrong.
No, dude, I think it's solid insight, Matt. I haven't really thought about it, from that perspective. I think there's an opportunity for you to develop some sort of like calculator. Boy, you could make $1 million, man, because there's all these balances and trade-offs, right? As you move up and down sort of the stack and all the stuff that you just described. So solid, brother.
Thanks, man. What do you think, Paul?
Yeah, I agree with you too. Size of model is going to make a difference now. I mean, models are getting more efficient and it's a lot more smarter than they used to be, and we've still got a long runway on that.
Yep.
Yeah.
And by the way, there's a benchmark out there. It's called ML Commons, and they do the organization's called ML Commons, and they have ML Perf training, ML Perf inference, and then there's storage, like check marking storage kind of benchmarks as well. Yeah. It's a great resource it's mlcommons.org, great resource for folks. What I would say is when NVIDIA or AMD or any other company goes out and touts having, world-breaking records on these benchmarks, that's really good stuff, but it should not guide your buying decisions. You should look at those numbers, look at the relative cost, and come up with your own metrics around what works best for you. So I'll shut up on that. And by the way, think of RAG and think of kind of vector search and think about some of the agentic and the way you're doing your inferencing and really kind of I would really set everything on that kind of lens and kind of work backwards, or that kind of perspective and then work backwards. And I'll shut up because IBM has 2 new birds. Holy hell, this has to be Paul. That Paul is. I love you, Paul.
Yeah, I know you do. I'm gonna start using really long, ugly titles from now on.
Oh,
Two new birds.
I love
Yeah.
it.
Yeah, IBM had a conference in Atlanta for developers only. Well, not only, but by invitation only. There was developers and leaders in quantum, and they made a bunch of announcements down there. One of them is that they're bringing out two new processors. One is called a Nighthawk, which is a bird, and a Loon, which is also a bird, in case Matt didn't know it. Anyway, these are the Nighthawk is they're both nifty processors. The Nighthawk is really developed to bring in quantum advantage, and the Loon is developed to pick up the roadmap where the Nighthawk leaves off and bring in deliver fault tolerance. The Nighthawk is IBM said it's the most advanced quantum processor it's got to date. It's designed to facilitate and run really high performance quantum software. Its goal is to deliver quantum utility and quantum advantage at scale. So quantum advantage is they're looking for classical or quantum programs that can beat any classical solution at any size or whatever. I mean, it's basically quantum beating classical in every case. So anyway, the Nighthawk is developed to bring that in. It's targeting like near-term utility improvements. It's supposed to solve real-world problems better than classical once it occurs. So it's got it's designed for modularity and for performance. The long-term plan is they'll connect multiple Nighthawk chips together to build a bigger system, and it's also designed so that they can run circuits with larger numbers and increase the number of quantum gates. So that's basically the plan for modularity and performance. The Nighthawk has 120 qubits. It's got something different. The chip topology is in a square lattice. Got 218 couplers. Couplers let the qubits talk to one another, basically.
Mm-hmm.
And the Heron processor had 176 qubits, couplers. And so this is going to advance over. The Heron had something called a heavy hex processor, and that's where the hex was based on tiling a bunch of hexagons, and a unit cell was based on tiling all these together. So it has less connectivity than does the new processor. They want to increase the two qubit gate fidelities. They want to have longer coherence times with the Nighthawk. Probably end up initially, I think, keeping existing coherence, which is around 160 microseconds. It will execute things faster. They'll have fewer swap gates, which means the circuits are going to be more complex than previous circuits. I should explain what swap gates are. They're fairly expensive in terms of taking quantum resources. Each swap gate takes like 2 or 3 2 qubit gates to implement, and they basically kind of waste resources because they don't actually, swap gates don't actually perform computation. They just kind of move data around to put it in position where it can be more easily accessed. And a swap gate will actually do some of the coherence budget. I mean, when you're doing a an operation in a second and a typical group of operations in 10 seconds, then you have, not 10 seconds, 10 microseconds. It has to be very fast. So anyway, that's the Nighthawk, and it's a about 30% improvement over what the existing Heron processor can do. The other bird is called the Loon. I think I would change the name with IBM on that one, but it's basically a proof of concept processor to test ideas out and configurations out for a quantum supercomputer or fault tolerance. It's a blueprint for building a massive fault tolerance machines, and it's going to validate some of the architecture they've got planned for it. The quantum QLDPC, the low density parity check codes that are used in error correction. They'll be testing some of that out. It's got, I think I mentioned it, it's got six-way qubit connections, got better layers of routing on chip circuits. And one thing it's got that's important is fast qubit reset. Excuse me just for a minute. I'm going to have to walk this dog out.
Sure.
What an episode.
I got a sign on my door, but they don't read that.
That dog needs to pay attention. Needs
Yes,
to read.
I know. Yeah. Anyway, it's got a fast qubit reset, and I won't go into a really long explanation, but you need to reset the qubits when you get through with an operation. It's like if you're in a car and you want to turn left and you turn the steering wheel left and you never turn it back straight again, you're always going to go in a circle and you're going to collide with something. And that's what happens when you don't reset the qubits that have been in an operation. There's a big long process that goes on in order to do that. So anyway, these are two new processors. They're both got really good architectures, and I think they're going to do the job for IBM. Like I say, one is the Nighthawk is going to bring in quantum advantage, and the Loon is going to bring in fault tolerance. So,
Well, just like your error correction being a lifelong adventure, I've been turning left my entire life in circles. So I'm there with you on that. By the way, a loon is a duck. Yeah, I would have gone with a more, I don't know, a stronger bird.
Yeah,
bird
like
prey.
fire eagle or
Yeah.
something.
Yeah. Or at least a vulture. I don't know. Vulture's kind of.
Yeah, I like Vulture. I like Nighthawk. I think that sounds really cool.
That reminds me
does
of
sound
with Knight Rider.
Yeah.
It does.
Anyway, hey, listen, fantastic. IBM's killing it. We're coming up to the end here. I know we're gonna have to move through quickly, but before we do, it's Thanksgiving week. I'm gonna put you two on the spot. Besides myself, I want you to tell me something that you're thankful for on this Thanksgiving week. You can't, again, don't talk about me. Just talk about something else you're thankful for in this world.
I'll start. I mean, I'm just thankful that for the last almost 10 years, I've been able to do what I truly love doing for work. That hasn't always been the case. For 30 years before I discovered my industry analyst, opportunity. So I'm just very thankful that, I can do this with you guys. Like I can write, I can do video work, and I'm looking forward to a very exciting 2026. So that's what I'm thankful for.
Right on. Right on. How about you, Paul?
I'm thankful for me.
Oh, that's a mic drop. That is awesome.
No, I mean, I've got 10 grandkids and one great grandkid. A great family, 3 daughters that are great. I have had a superb life. I mean, literally. I mean, I could wish for something, I wouldn't have anything to wish for.
Awesome.
Will you wish on my behalf? I have a list I can give you.
And I'm also thankful for these house shoes that I'm wearing today.
You kind of stole my thunder. I'm kind of thankful for just it all. I mean, it's like sometimes you get caught up. It's like I was in this phase about a week ago, traveling everywhere, no rest, you're working hard, you got all these personal things going on, professional things going on, and it's easy to feel overwhelmed and like miserable. And then you step back and you're like, you know what? I got it pretty good. I'm complaining about the wrong things.
Worse, yeah.
Yeah. So, yeah, I'm thankful for how blessed I am. And yeah, anyway, that's
I told my kids one time, if you have to walk every place you go, you're going to be thankful that you've got a bicycle. If you have to ride a bicycle every place you go, you'll be thankful for a car. So regardless of what you've got, there's always something more that.
All relative.
What if you have a car?
All relative.
What if you have to drive everywhere in a car? What do you do?
Well, you can have an airplane.
I'm waiting for teleporting.
Yeah.
Anyway.
Yeah.
Hey, listen, guys, fantastic conversation. Thank you for the time. We're going to close out this podcast by saying, if the last 45 minutes didn't convince you, we have no idea what we're talking about, and you shouldn't take our advice for investing, then God bless you. Go at it, and you're on your own. And there goes Paul sword fighting again.
Yeah.
But we do ask that you like and subscribe. We do. Sorry, I had to do it.
And let's ask Paul's dog. Let's ask Paul's dog to like and subscribe because he's interrupted us a couple times.
Yeah, what's his name? What's his name or her name?
Kyle.
Kyle?
Mm-hmm.
That's my project manager's name. I love it. Kyle's going to be the fourth on the next podcast. Like and subscribe, please. Even if you don't like us, like and subscribe. But then you can go on Twitter and complain about us. But yeah, please like and subscribe. And we will see you in a couple of weeks. And happy Thanksgiving to everyone. Oh, and wipe your eyelids. What were we going to say?
Oh.
Take care, all.